let's rev it up. Go about 2.5. There we go, we can see it's about 2.5. Rev it up a bit more, 3.5, and then back off. Back down to idle. So there we go, we have an API for our car. Hi, welcome back to the channel. Today we're going to be discussing AutoCoder. AutoCoder is an open source project for building a custom head unit for your car. Okay, so what really is AutoCoder? AutoCoder is a small open source project that I started recently. With the main aim for me was to generate a custom head unit for my car. I wanted to use web technologies that I use on a daily basis. So one of the key objectives was to be able to create an API layer that can talk to the car's COM interface. And then people can build their own custom UIs just using standard HTML, CSS, JavaScript on top of that. Okay, so let's jump into the project. I don't have it cloned yet on this machine, so let's just grab that quickly. Let's clone the repository, AutoCoder. So we'll pull down AutoCoder. And we'll open up the project. Okay, so let's go into the project now. So when we load up the project here, what we can see at the top level, we've got a couple of directories. We've got the UI directory. That's still very much a work in progress at the moment, so we won't go into there for now. And then we've also got our AutoCoder API directory. If we open up this, we can see that actually what I've decided to use for this project is Go. I'm a real fan of Go at the moment. Go is a really nice language, especially for building things like small REST interfaces or REST servers to run locally. So what we've got here, if we open the Go module file, we can see a couple of things here. I've used Gorilla Mux. Mux is a brilliant library for creating REST interfaces, makes it really easy, really quite a clean library for you to use. The other thing I've got here, which is a fork of a different repository. There's a project on GitHub called ELM327 and ELM327 is a really nice Go library that someone's created for talking to OBD2 devices. I did have to make a couple of modifications for it to work. Also using an OBD2 simulator, which we'll talk about in a bit. So there is a forked version of that on my GitHub. A couple of other simple things, serial and sys. We don't really need to go into those. So we're going to open up the Go main file at the moment, and this is just how it stands at the moment. This project is very much in an early stage. And a lot of the functions going to move, going to go into their own individual packages. But really, this is what I have done just to get it started and just to prove that we can actually get an API interface that can talk to the car. Okay, so let's jump down to main now. So in the main function, we can see there's a couple of flags that you can actually set when you're starting up the OBD2 API server. And couple of important things here. We've got the ability to set different devices. There's some examples in here. We've got the TCP, so we can actually talk to an OBD2 device that's on a network connection. And that's what we'll be using when we use the simulator, because the simulator runs as a TCP connection. Or we've got the serial port. This is actually our serial port address for the ELM327 device. If you've got one of them that plugs into USB, something like this, just a USB ELM device. You can also get Bluetooth versions, so wireless version. Now, obviously, depending on what device you use, the serial COM port will actually change depending on that device. So for me, tends to end up on serial 3, but we'll go through that when we actually get it up and running. Next up, we actually just create the API. Creating the API is is where we start to actually use the mux functions. So in mux, it's really simple. We say, okay, we're going to create a new router, and then we're going to add some handle functions. So we've got two functions that we're going to start with. We've got our start OBD, so that means that that'll actually initiate the comms. And then we've got a function at the moment called all car data, and that is a GET request. So let's first look at our start OBD. So when we start our OBD, what that's going to do is going to kick off a couple of things. It's going to kick off two different data collectors. We've got a data collector called fast data, and we've got a data collector called slow data. And they quite literally are two different tickers. The first one, our fast data, at the moment we're using for getting the RPM. And then our slow data one we're using to get the coolant temperature. So we can see at the moment 100 milliseconds for the fast data, every second for the slow data. Okay, so once we've got our fast and slow data, all we're going to do then is we're going to return a status OK to mux, and that will actually return on this API our 200 request. Once we've started the OBD, we can now call out all car data. So all car data is a really simple function where all it's going to do is if the OBD is running, it's going to encode into JSON the structure from car data. So car data is at the moment our very simple structure that just holds the values RPM and coolant temperature that are set by our two tickers, the slow and the fast data. They're returned to mux and returned as a GET request with a 200 response. Now, to actually get values from the car, we've got some very simple functions to start with. At the moment, we only have two. We've got get RPM and get coolant temperature. So we'll jump into one of these, and get RPM uses some functions in the library where we can actually say, okay, I want to create a command that's called new engine RPM. That's built into the library. And I want to run that OBD command. So send in this function here will return us the value over the OBD2. It will wait until that value is returned. Once the value is returned, we're actually going to write directly into car data the value that we've now got for RPM or the value that we've got for coolant temperature. Okay, so that's a quick rundown on how the code works. It's quite a simple REST server, and at the moment it's very monolithic in shape at the moment, just being a big single package. Over time, I really want to split it out into lots of smaller packages, make it far easier to get custom bits of information or even integrate custom libraries, because certain age cars just don't use OBD2. It's really only the more modern sort of mid-90s onwards cars that tend to have the OBD2 connector. So this will change. It will change over time. But really at the moment, it's a good example of how I can make a little API that can query my RPM and my coolant temperatures on the car. Okay, so next up, we can have a little look in the README. In the README, it's quite simple at the moment. There is a library that's really helpful for this so that you don't actually have to have your car plugged in all the time. There is a library someone has built called ELM327 Emulator. So if we'll just open up ELM327 Emulator, the link going. So this is a project on GitHub, and it's a really nice little project. Got me going a lot quicker because I didn't need to go and sit out in the car and have my car plugged in all the time. It did mean there was a couple of changes to the library that we're using, but they're now integrated and you should be good to go. So what we're going to do, we're actually going to install this package. So we're going to open up our terminal. Let's just jump into the terminal, and the installation is really quite simple. Let's grab that command there. So we're going to pip install the ELM327 emulator. That's going to run through and do its thing. Cool, so that's installed. And that's really all we need to do on here. So we can jump back into the README, and you'll see this command here. This is how we're going to run the simulator. So let's copy that into our terminal. Allow the access. And we now have the ELM simulator running. So this thing is sat here and it is emulating our OBD2 connector, and it's actually on a TCP connection. That's how we're going to connect to it. So if we go back into our main Go application, we're going to comment out this line here, and we're actually going to change over to using the TCP connection. Now it's a local connection, so 127.0.0.1 is usually good. And as specified when we started the command, we can see here we say it's going to be on port 35,000. So we obviously need to match that port in the TCP connection. So we can now save that. Okay, so now we've changed that, we can actually open a new terminal and we can actually run our application. So we're going to change to the AutoCoder directory just to make it easier. And then we're going to type go run main.go. Hit enter. We'll allow access. And now that's running, we can open Postman. Postman's generally the tool I like to use the most for sending API requests. Okay, so now we've got Postman up and running, we can actually create a new API. Now I've already got this created ready to go. But as you could see before in the code, we created an API called start OBD. So the REST server is created and it's set to run on port 8080. It's only running locally, so 127.0.0.1 is good. So we can see here we're not getting anything coming out of the console, and we can hit start OBD. Now that will send our request, which we get a return 200 OK. And we can now see that the Edge server is up and running, and it's actually sending commands to the car OBD2 simulator. So now we can see those commands are actually running. We can go back into Postman, open up our other requests. So this is our GET request, again on 127.0.0.1, port 8080, and it was called all car data. So when we hit send on this one, we can actually get an RPM value and a coolant temperature value. Now these are just simulated values that come from that simulator Python package, but every time we hit this, we should see a different value come back, simulating a car that's running. Okay, so we've jumped in the car now. So what we're going to do, I've got my laptop, I'm going to grab my OBD2 plug, and this OBD2 plug plugs in the Fiesta. So we're in a Fiesta Mark 6. The OBD2 plug is just under the center column here, and when that plugs in, we should see some lights appear on the OBD2 reader, depending on what reader you're using. I'm going to plug that into my laptop here, and you may need to install some drivers onto your machine. I already have them installed on this one. At the moment you have to actually use WSL for this project. So what we can see here, if we open Device Manager, we can see that the serial port is on COM port 3. So when that actually goes through to the Linux kernel, that appears under -dev-tty-s3. So we've commented out the TCP and we've turned back on serial S3. Now what we're going to do is, we're not going to use PowerShell, we're going to open up a new WSL terminal. We're going to change directory into AutoCoder API, and we're going to say go run main.go, hit enter, and now that's running again. We'll allow access. And so what we need to do, same as last time, we need to actually call our post request for start OBD. So we'll put start. Now a good sign for this is when we come back in here, we should see that there should be some commands that are actually running. Now this is currently saying I'm unable to connect. Is the ignition on? No, the ignition's not on. Let's just switch the car on. So ignition is on. So here we go, we've got values coming out. I've not actually started the car yet. So first thing we're going to do here is we'll hit all car data, And we should see we've got coolant temperature 21 degrees and RPM 0. Let's start the car up. So we can see here the car's idling about 750 RPM. Let's rev it up. Go about 2.5. There we go, we can see it's about 2.5. Rev it up a bit more, 3.5, and then back off. Back down to idle. So there we go. We have an API for our car. Okay, so there we have it. We've got an API running and it's getting values for our car. So because it's just an API, we can start to use completely standard web technologies in order to start building user interfaces, get some dials on there, and I really look forward to growing this project with you guys. If you're interested in this project, do hit subscribe, check out the Git repository in the description below, and thanks for watching.